Hello everyone, welcome back. So in this video we are going to learn about Fermilevel in intrinsic semiconductor. Fermilevel in the case of intrinsic semiconductor. Okay, so if you are first time to my channel, please consider subscribing. So we have seen in the previous videos the concentration of electrons in conduction band is given by N is equal to Nc into e power Ec minus Ef by kT. Similarly, the concentration of holes in valence band is given by P is equal to Nv into e power Ef minus Ev by kT. Okay, so these are the formulas for concentration of electrons and holes in conduction band and valence band respectively, okay, in a given semiconductor. So for what is the condition in the case of intrinsic semiconductor? So in intrinsic semiconductor, number of free electrons is equal to number of holes, that is N is equal to P. So from these two equations, so substituting here, we'll have Nc. So N is equal to Nc into e power minus Ec minus Ef by kT is equal to Nv into e power minus Ef minus Ev by kT. Okay, so Nc by Nv I will take this side and I will send this term to the opposite side. So what does this term become? So this is e power, so this is minus into Ef, so it will be Ef only. Okay, so Ef and minus into minus becomes so minus Ev, same Ef minus Ev doesn't change. So here when you send this term this side, so it becomes now, so it becomes by kT. I'll write one step here. So kT divided by e power minus Ec minus Ef by kT. So Nc by Nv is equal to e power minus, so e power minus Ef plus Ev. So this becomes when you take this term to the numerator side, so it becomes plus Ec minus Ef divided by kT. So Nc by Nv is equal to e power so this becomes minus 2Ef plus Ec plus Ev divided by kT. So taking natural log on both sides, so ln of Nc by Nv is equal to minus 2Ef plus Ec plus Ev divided by kT. So send this kT that side, so kT ln of Nc by Nv is equal to Ec plus Ev minus 2Ef. Send this term to the left hand side and this term to the right hand side. So rearranging, so we'll have 2Ef is equal to Ec plus Ev minus kT ln of Nc by Nv. kT ln of Nc by Nv. So it implies Ef is equal to Ec plus Ev divided by 2 minus kT by 2 ln of, that is natural logarithm of Nc by Nv. Okay, so this is the formula for Fermi energy level in the case of intrinsic semiconductor. Okay, so now we have seen the Fermi energy level in the case of intrinsic semiconductor is Ec plus Ev by 2 minus kT by 2 natural logarithm of Nc by Nv. Okay, so this is the generalized formula. So now we'll take some special cases. So when Mn is equal to Mp, so when Mn is equal to Mp, that is effective mass of electron is equal to effective mass of hole, then what will happen? Nc becomes equal to Nv. Okay, so this we have seen in the previous video. In effective mass concept, I have explained you about Nc and Nv. Only difference between Nc and Nv is, so in their formulas we have Mn and Mp respectively. Okay, so if Mn is equal to Mp, then Nc becomes Nv. So when Nc is equal to Nv, then natural logarithm of Nc by Nv becomes ln of 1, which is equal to 0. So this becomes 0. So when this becomes 0, then what will be the value of EF, that is Fermi energy level, EC plus EV by 2. Okay, so this is the formula for Fermi energy level in the case of intrinsic semiconductor. Intrinsic semiconductor, that is Fermi energy level. Fermi energy level exists in the center of forbidden gap. Exists in the center of forbidden gap. Okay, so if you draw the energy band diagram, so this is EC, this is EV. So Fermi energy level exists in the this gap is called as forbidden gap. Okay, so this gap is called as forbidden gap. So Fermi energy level will exist in the center of this forbidden gap. So exactly in the center of EC and EV. So this condition exists only when Mn is equal to Mp. Okay, so this is very important. For all the conditions, the forbidden gap is not at the center of the Fermi energy level is not at the center of forbidden gap. For only the values when Mn is equal to Mp, then only this will be possible. Okay, the second condition, at T is equal to 0 degrees Kelvin. When T is equal to 0 degrees Kelvin, also this term becomes 0. So this total term becomes 0. So then also EF is equal to EC plus EV by 2. So in this case also the Fermi energy level exists in the center of forbidden gap. So this also results in the same value. So conclusion here is, the important point here is the Fermi energy level in intrinsic semiconductor. Fermi energy level in intrinsic semiconductor lies in the lies at the center of forbidden gap, forbidden energy gap, when, so this happens only when first condition is Mn is equal to Mp or Nc is equal to Nv. Okay, and second condition when T is equal to 0 degrees Kelvin. So under these conditions only the Fermi energy level exists in the center of forbidden gap, and for all other values, so EF is given by this value, EF is equal to, this is the generalized formula, so this will be okay. This holds good for each and every value of T and Nc and Nv, and these are the special cases of Nc and Nv. So if effective mass are same, then forbidden energy gap exists in the center. Okay, and also when T is equal to 0 degrees Kelvin. Okay, so this is about Fermi energy level in the case of intrinsic semiconductor. In the next video we'll see the Fermi level in the case of n-type semiconductor. Okay.